In this video, I'm going to take you through some of the examples in the 1.1D lesson, which is linear equations in real-world contexts. We are going to skip to the last part of the lesson where the word problems are already built, and then next week we'll look at the word problems or the questions that have you create your own word problems, so 7 through 11. I'm going to mainly focus on the setup of these. I think we should be able to solve these. I would like you to solve them. And then feel free to check the key that's on Google Classroom. And it says we're going to write expressions for each unknown quantity and an equation that represents the word problem. We're going to solve it with all of our steps and write a complete sentence. The first one says the length of a rectangle is 4 meters greater than 5 times its width. Find the dimensions of the rectangle if the perimeter is 20. So the length and the width are my unknown quantities. And the length is talked about in reference to the width, so we will have the width be the variable. And it says the length is 4 meters greater than 5 times the width. So 4 plus 5w or 5w plus 4 is the width. And then we're going to build an equation that involves the perimeter, which means that we need to double each of these sides because it has 4 sides, 2 of each. So my equation is going to be 2 times 5w plus 4 plus 2 times w. I don't need those parentheses, but I'll put them, equals 20. And I'm going to solve that, and whatever I get for my answer, I'm going to take that and plug it back into the length to find the second answer. So if the answer comes out to be 1, then I would take that and plug it in up here, and I would get 5 times 1 plus 4 is, let's say, 9. Okay, and then you're writing sentences. Let's look at the setup of the second one, number 8. There are 8 fewer students in the debating club than on the math team, and there are only half as many students on the ecology force as in the debating club. How many students are in each group if there are 68 students in all and each student participates in only one of the activities? So this would be number of students in the math club. Debate. We want to do this with one variable, and the debate is in reference to math, so we might start with, let's try to have the variable be for math. Debate is 8 fewer, but that is m minus 8, not 8 minus m. Has to be in that order. And then ecology has half as many, so that would be m minus 8 over 2. So ecology is half as many as in debate. Or we could do m over 2 minus, and take half of this, which would be 4. Either of those would work. Seems like this might be kind of the most obvious one. Could also do 1/2 times m minus 8, like so, which would explain where that came from. So our equation is we're going to sum up all of the clubs. So the first club is math, the second club is debate, and the third club is ecology. And we solve that showing all of our steps. You don't have to use parentheses here, but it maybe just helps show that you have included all 3 clubs. Again, finish solving it, write your sentence, and check the key on Google Classroom. Let's look at number 9. Number 9 deals with a triangle, so 3 sides. It says the first angle of the triangle is 20 degrees more than the measure of the second. The measure of the third angle is 30 degrees more than twice the sum of the measures of the first 2 angles. So we have the measure of the first angle, the measure of the second angle, and the measure of the third angle. So it seems like maybe defining this, pick whatever lever you like, so define the variable to be the second angle because the first one is in reference to that 20 more than, so either x plus 20 or 20 plus x. And then the third angle is 30 degrees more than twice the sum of the first two. So we're going to find the sum of the first two. We're going to do twice or double it, and we're going to do 30 degrees more. So our equation would be for the whole triangle, remembering that the angles in a triangle add up to 180 degrees. It would be my first angle x, my second angle x plus 20. These could be in any order. And my third angle, which is 2 times x plus x. I could actually combine those if I want to. There's the whole thing. I solve for x. That would be my second angle, and I'll plug it back in to find my other two angles, and I'll write my sentence. So that's just the setup. Go ahead and finish solving that. Number 10. Sam got a 90% on his first exam, 76 on the second, and a 92 on the third. What must he score on his fourth to have an average of an 88? So we'll write out his first exam was a 90. The second exam was a 76. The third exam was a 92. And the fourth exam is what we're looking for. We'll call that x. We want the average to be an 88. So we're going to sum 4 of these. So to find an average, we add up everything we've got. And we divide by the number of items or number of tests. In this case, there's 4. And we would solve this. Please keep in mind that this, it's kind of in some imaginary parentheses, so when we go about solving that, just be aware of that. We solved some of these in the 1-1C lesson. Last one, let's talk about the setup on 11. Kelly works 40 hours a week as a nurse practitioner. She earns time and a half for every hour she works over 40. If she worked 60 hours in 1 week and made $3,360, what is her regular hourly wage and her overtime wage? So her regular pay is X, and her overtime pay is time and a half. And 40 hours a week at the regular, and she worked 60. So that would mean we have 40 hours at the standard rate, X, plus 20 hours, that gets us to our 60, at the overtime rate, equals 3,360. We'll solve that. We'd have to plug it back into both of these let statements and write our sentence, and it does want both the regular and the overtime. All the work and the answers are in Google Classroom. Hopefully this helped explain how to set up equations for the 1-1D lesson.